Hello friends, I am here with the class 10 topic quadratic equations chapter number 4. In this video we will discuss about the nature of the roots of the quadratic equation. So let's start. We know that the standard form of the quadratic equation is ax square plus bx plus c is equal to 0, where leading coefficient, that is a, should not be equal to 0. And we also know that the quadratic formula is x equal to minus b plus minus square root of b square minus 4ac upon 2a, where b square minus 4ac is called discriminant, capital D, and it is called discriminant. So nature of the roots depends upon the discriminants. So there are three possibilities of the discriminant. The first condition is if D is equal to b square minus 4ac is greater than 0. Then it has two distinct, different real roots. So again I'm saying if D is greater than 0, then it has two distinct or different real roots. I've taken one example here, x square minus 5x plus 6 is equal to 0. If you'll calculate its discriminant, D is equal to b square minus 4ac, so value of v is minus 5 here, b square minus 4, the value of a is 1, c is 6. So when we will solve it, answer is coming 1. So discriminant is coming greater than 0. Then it has two distinct, because when we'll substitute the value of discriminant in the quadratic formula here, so square root of 1 will be the 1. So it means one time we will add 1 and one time we will subtract 1. So one time addition and one time subtraction. So from here we can retain it. It has two different real roots. And example is here, x square minus 5x plus 6. When we have solved it by the splitting middle term, so two different real roots are coming, that is 2 and 3. So again I am saying when discriminant is greater than 0, then it has the two different real roots. Discriminant is greater than 0, then one time there is addition and one time subtraction. So from there we can retain it. It has the two different real roots. Now the second one is if discriminant is equal to 0, then it has the two equal real roots. If D is equal to 0, then it has a two equal real roots, because if discriminant is coming 0, so square root of 0 is 0. It means when we'll add 0 and subtract 0, there will be no use. It means we have two same real roots. When we'll add 0 or minus 0, there will be no change in the given values. So it has the same real roots. For example is there x square minus 4x plus 4 equal to 0. When we'll solve its value, discriminant you will calculate b square minus 4ac, its answer is coming 0, and we have solved this by splitting middle term. So you will see the two same real roots are coming, x is equal to 2 and 2. So if discriminant is 0, so there is no addition and subtraction in the quadratic formula. So if no addition and subtraction, so it means we have same real roots. There are two cases. When total there are three cases, but first case is when discriminant is greater than 0, so one time addition and one time subtraction, so it has a two different real roots. But when D is equal to 0, no addition subtraction in the quadratic formula, so it has the same real roots. And the third case is when discriminant b square minus 4ac is less than 0, so it has no real roots. Very important word is a real. It has no real roots. So for example is x square minus 3x plus 10. I have taken the equation. When we calculated its discriminant is coming minus of 31, and substitute the values in the quadratic formula, that is minus b plus minus square root of b square minus 4ac, that is called discriminant upon 2a. So value of v is here minus 3 and minus of this and become positive plus minus square root of minus 31 upon 2. So when there is a negative value inside the square root, so my answer will not be the real. Its answer is the imaginary value that you will discuss in the class plus 1 class. So when inside root there is a negative value, we will say that no real roots exist. So when discriminant is less than 0, it has a no real roots. Again I am discussing all the 3 points. When discriminant is greater than 0, it has a two different real roots. And when discriminant is equal to 0, it has two equal roots, same roots we can say. And when discriminant is less than 0, it has no real roots.